Okay, we're going to look at the properties of a logarithm. Oops, actually, it's not the properties of a logarithm. These are equations with logs and exponentials. All right, so the very first question, first question that we have is a to the 2x minus 5 equals 32 to the x minus 6. Now, if you're looking at the directions, it said that we want to try and make the bases match each other. So, if we're going to do that, see if we can make the 8 and the 32 with the same base. Now, 8 is equal to 4 times 2, and that's 2 times 2. So I know that 8 can be written as 2 to the third power. So then if I look at the number 32 and think about breaking that down, that also can be written as power of 2. That's 2 to the fifth power. So now we could say, well, 8 is 2 to the third power to the 2x minus 5, and 32 is 2 to the fifth power to the x minus 6. But using our properties of exponents, this becomes, well, these will end up being able to multiply. So this will be 2 to the 6x minus 15 equals 2 to the 5x minus 30. And since we have the bases matching each other, we're able to say that the exponents must be equal then, since exponential functions are functions and they're one-to-one. So then we just have to solve this like regular. So let's try and put all of our variables onto one side. So we're going to move over our x's. That leaves us with the x minus 15 equals negative 30. We add the 15 over, and we end up that x is equal to negative 15. And before I box that up and make sure that there's no problem, so I'm like referring back to the original problem, and if there's any issues with x's. Well, exponential functions have a domain of all real numbers, so it doesn't seem like there should be a problem. So x is equal to negative 15. For this next problem, if we're looking at the bases, we have a base of 3 and a base of 5. Now, there's no way to make those match each other, so we can take a log of both sides. Now, natural log or log with base 10 are both good to use. And the reason that we want to use them is because there's a rule for logarithms that allows us to take the power of whatever our argument is, and that power can come to the front. So if I look here, I have 5 to this 2x power. Since I have the log in there, I could bring that to the front. And again, I'm allowed to say a natural log of both of these things since both quantities were equal to begin with. So what I have now is 6x plus 5 times natural log of 3 equals 2x times the natural log of 5. Now, natural log of 5 and natural log of 3 are just numbers, so we can treat them the same way that we normally would. So when I look at this, I want to distribute. So I'm going to have x times natural log of 3. Oops, I forgot my 6x. Plus 5 natural log of 3. And then here I have 2x natural log of 5. So I want to put my terms that have x all on the same side. So we're going to have 5 natural log of 3 equals 2x natural log of 5 minus 6x natural log of 3. Since these both have x, I'm going to factor that out so that way I can try and solve for x. So this is 2 natural log of 5 minus 6 natural log of 3. Because I took the x out. And so the last thing would be to divide by 2 natural log of 5 minus 6 natural log of 3 on both sides. So don't just get scared because you see natural log in there. It's really not too bad. It's very similar to what you would do with the normal numbers. So this is the exact value for x. Then you can punch into a calculator and get an approximation.
You kill me.
All right, so for this next equation, what we want to be able to do is get a logarithm on one side. So we have a single log right here. So in order to do that, let's try and move some things around. We're going to first take away the minus 20. So that cancels out, and then it's 2 times log base 8 of 3y minus 5 equals 4. So then we're going to have to divide by 2. That makes that go away, both sides. So we're left with log base 8 of 3y minus 5 equal to 2. So as soon as we have one single logarithm on the left side, we're going to use the meaning of log. So remember, log base A of b equals c means we have a to the c power equals b, right? This is the base, the exponent, and then the answer to that. So this is the exponential form. So to rewrite this, we have our base is 8. It's going to go to the second power and should equal all of that stuff. So we have 8 to the second power equals 3y minus 5. But really that's 64 equals 3y minus 5. So we try and get y alone, just a linear equation here. Add 5 over, we get 69 is equal to 3y. Divide by 3. We get that y is equal to 23. For this next equation, we have a log on this side, and then we also have a log on this side. So we're going to try and put all our logs together on one side. So we're going to move this entire chunk, log base 2 of w plus 2. We'll add it to both sides here. And so then that will cancel that out here, and we'll have log base 2 of w plus log base 2 of w plus 2 minus 3 equals 0. So we're going to add the 3 over so that way all our logs are together on this one side of the equation. And so we have log base 2 of w plus log base 2 of w plus 2 is equal to 3. Those cancel out. Now there's a property of logarithm that says if you have two logs being multiplied, log base a of m plus log base a of n, not multiplied, added, you can write that as a single logarithm with that same base, but now as a product of that m and n. So for us, what that's going to look like is log base 2 of w times w plus 2 equal to 3. Now, using what we saw earlier, the definition of log, we can rewrite this as 2, that's our base, to the third power equals that. So that will look like 2 to the third power equals w times w plus 2. So this means we're going to have 8 is equal to w squared plus 2w. Now this is a quadratic equation, so we need to make it equal to 0 on both sides. This is 0 equals w squared plus 2w minus 8. So I knew it was a quadratic because of that power 2. And so if we make it equal to 0, we can try and factor. If you don't want to factor, you can use quadratic formula to try and solve. But this will be w times w makes w squared. And we need a 4 and a 2 to make an 8. And add to a positive 2. That would be a positive 4 and a negative 2. So that gets me w will be either negative 4 or positive 2. Now before I box those, I need to think about what the original equation was. So going back to the very beginning here, we need to make sure that both of the values negative 4 and 2 are okay. When we say okay, what we want is that you're always going to be taking log of something positive. It doesn't make sense to have a negative number inside here because it's the answer to an exponential expression. So if I look at what I have, log base 2 of w minus 3 equals negative log base 2 of w plus 2. If I put negative 4 in for this w, that would be bad. It would be taking log base 2 of a negative, so I can't have -4, so that would be an extraneous solution. The w being 2 seems okay, so that's going to be my answer. So I have w equals 2, the answer to that. Okay, we're moving over to question number 3. Still more equations with log in it, but this time there's log on everything. I do notice this coefficient in the front. Right away, it's making me want to use that property of log that puts the exponent on the back. So thinking about this as log base 3 of 4 to the 1/2 power. But that's even simpler. That 4 to the 1/2 is equal to the square root of 4, which is 2. So I'm just going to rewrite this as log base 3 of 2 at the very start of my problem here. Log base 3 of x minus log base 3 of 2x plus 6. So now that I have all logs on the left side like that, I could just combine those using our properties of log that says if we have log base a of m minus log base a of n, we can rewrite this, we can rewrite this as log base a of m over n. So we're going to have up above here, using that property, that this is going to be log base 3 of x over 2x plus 6 equals log base 3 of 2. Now this is different than the previous problem. Since we have a log and a log, what we're able to say is that these arguments then must be equal to each other. So we'll rewrite this as x over 2x plus 6 is equal to 2. Now this is a rational equation, so we're going to clear out the fractions on this one. We're going to multiply by 2x plus 6, and then multiply this right side also by that 2x plus 6, which gets rid of our fraction, and we have x is equal to 2 times the 2x plus 6, which will distribute. We get x is equal to 4x plus 12, which is now a linear equation. Get our x's on one side, subtract the 4x, we get negative 3x is equal to 12, divide by negative 3, and we have x equals negative 4. Now before I box that, again I want to check for those extraneous solutions. So looking at negative 4, it's not going to work. If I go back to my original, if I stick a negative 4 in there, I'll be taking log out a negative number. So that means that there will be no solution here. Okay, this looks like an interesting problem. So notice that it has log base 3 of that stuff. So right away, I see that there's no log on the right side. So I'm going to rewrite this using that exponential form. Let's go back here. 3 is my base. So we're going to have 3 to the exponent 0 equals that whole inside. So that would look like 3 to the 0 equals natural log of x minus 2. But really, that's just equal to 1. 3 to the 0 is 1. And then we have natural log of x minus 2. Now remember that natural log is really a log with the base of e. And so if we rewrite this, again, using that exponential form, e to the power has to equal x minus 2. So that's e to the power 1 equals x minus 2. Well, e is just a number, so if I want to get x alone, all I have to do is add 2 to both sides. And so we're going to get x is equal to e plus 2. Or we could say it's approximately, so this would be the exact value. Or you could say that x is approximately, we could put that into a calculator to get the approximation, which I'm missing right now. Okay, so we're going to look at the last problem, which we might do together during one of our classes lecture, but we'll try this together here. So it says, assume that you got an inheritance of $3,000 from your grandmother after she passed away. You want to be responsible and not spend it frivolously, so you decide to invest it in an account that earns an interest rate of 6.5%, which, by the way, is 0.065 if we write that as a decimal. Now it says that we are going to be compounding continuously, which gets us this equation that our amount of money will be equal to our principal, E, the number E, to the RT power, where R is our interest rate yearly, and T is our time in years. So it wants to know how long it will take for our money to triple. So if I have $3,000, if that's going to triple, that means I want to know when I'm going to have $9,000. Again, we know that the principal is starting out at $3,000. So we have the $3,000 was the principal amount, E, the number E. Our interest rate is 0.065, and we want to know how long it will take before it triples. So we have now this exponential equation to solve. So we can try and we can get rid of this 3,000 first. Let's divide by it. So over here, we'll divide by 3,000. So we're going to get 3 equals e to the 0.065 t. Now, we talked about earlier that if you want to make an exponent come down and use the log rules, where log base a of m to the n equals n log base a of m. If you want to use that property, we can take log of both sides or natural log of both sides. So if I take natural log of 3 equals natural log of e to the 0.065 t. And so what's really nice on this one is because this is log base, natural log is log with base e, those will cancel each other out. So then we're going to end up that this, well, I mean, you could bring it to the front and then do it, but we have 0.065 t equals natural log of 3. So then we divide by 0.065, divide by 0.065, and we end up that t is whatever natural log of 3 divided by 0.065. And I'll have to get a calculator to find that approximation. So again, that's the exact value. So if I really want to know how long it is, I need to go find my calculator and put in the approximation. So then this will be about, I just found my calculator, about 16.9 years. And let's go back and find the approximation. For this one, we have e plus 2. So when you enter that into your calculator, that's going to be, well, you should enter as e to the first power. So I'm entering e caret button 1 and then add 2 to that answer. So 2.7 about plus 2, so it'll be about 4.72. And I think we had one more. That first one there, if I'm going to enter that on my calculator, I would put parentheses around that whole entire denominator. So that's going to be 5 times the natural log of 3. And then you're going to be dividing that by 2 times natural log of 5, which it will automatically put a parenthesis right after natural log. So close that up each time here. And minus 6 times the natural log of 3. It looks like it should be about negative 1.63.